Hello, Fruitport High School students. Welcome to our next lesson. I'm going to make a video where you'll look at the screen below. This is about the phase diagram. Now, what I really love about teaching the phase diagram is that it's a good prep for advanced, standardized tests, because the phase diagram is our first graphs this year that have 3 variables, not just 2 variables, and those show up on standardized test questions. So, phase diagrams with states of matter. So here we go. I'll move the camera back down to this sheet here. So if you want to make your own phase diagram, you can get a big, giant graph. And you'll want to, we're going to do a lot of labeling on this here. So I'm going to use the whole sheet of paper. And on this axis, we have temperature that's increasing on this one. And on this axis, we have pressure increasing on this axis. And what makes a phase diagram special is that pressure, one variable, and temperature, the other variable, helps dictate 3 states of matter. Okay. So there's always kind of a point here. Sometimes this line is straight, sometimes it's curvy, and typically we have a line that comes fairly straight off of this one, and then we have a curving line that comes off of this one here. Okay, and you might see the 3 different zones. And if I asked you in class, you probably could. If I had a low temperature and a high pressure, what state of matter would be molecules moving slow and close together, colliding a lot? And this zone is the solid state of matter. Okay, what if I did the opposite? What if I had a really, really, really high temperature, but the pressure is low? So not a lot of collisions, even though they're moving fast. Well, that must be the gas or vapor state of matter. And that leaves this phase to be liquid. Okay. So the first questions on quizzes and homeworks are going to be, well, what if I give you this exact temperature and this exact pressure? Where would they meet? You're like, oh, that means it's solid. Or if I meet at this temperature and this pressure, they would meet about here. That would be a liquid. And so we can have different states of matter based on different pressures and different temperatures. Okay. Now, the next part of our notes here is, what if I gave you a certain temperature and a certain pressure where you ended up right on the line, like right here on the line? If you're on the line between solid and liquid, will you be a solid or will you be a liquid? And the answer is you'll be both. Both solid and liquid will be coexisting. And if you cross the line, we do a phase change between solid and liquid. So if we go from solid to liquid, we know that's called melting, right? Or if we go from liquid to solid, we call that freezing, right? So depending on which way we cross the line, are we going in this direction or this direction, we can melt or freeze. This is often called the melting freezing line, okay? What about a liquid turning to a gas? Maybe you remember that means evaporate, but we're going to use the word boil, right? But we learned 3 words. It could be evaporation or boiling or vaporization. And going from a gas to a liquid, that's condensation. All right, so if you're on this line, from this point anywhere on this line, you would be boiling or condensation, depending on which direction you cross. And solid to gas, we call that sublimation. It doesn't happen too much. And the opposite is deposition. And that's a new term for us there. Okay. There's a couple of unique points on the phase diagram we should know. And this one is right here. We have this spot where the melting freezing line, the boiling condensation line, and the sublimation line all hit each other, and this is known as the triple point. And the triple point is not a code for something fancy. It's really straightforward. That is where all 3 states of matter would coexist. And that can only happen at a very unique temperature and a very unique pressure. And I've drawn a general phase diagram. Maybe someone should have called me on that, and I should have a title, and I should call this would be the phase diagram of a general substance. There's no numbers, and they take on this general shape. I've seen the triple point of water. It's really weird. And if you have boiling water and you throw an ice cube in, that's not the triple point. This would be a triple point where all three states of matter coexist forever if you stay at a certain temperature and pressure. I saw it in college. It was really weird to see boiling ice water. It was ice water that was boiling and condensation. You could see ice cubes melting. You could hear them freezing all at the same time. It was pretty cool, but you need a very exact temperature and pressure. Okay. You'll also have a dot on the melting freezing line and a dot on the boiling condensation line at the same pressure. Now, any dot on this line would be its melting point or its freezing point. But if you're exactly 1 atm of units, this is considered normal room pressure, right? 1 atm is normal room pressure. And if you were to kind of like eyeball it across or use grid lines, where normal pressure hits the melting point, we'll call this the normal melting point, right? The normal MP for short. And that normal melting point is because the pressure is normal, you could come down and see where the temperature would be, okay, if there were some numbers. And this would be the normal boiling point right here. Again, it's that normal means where boiling, again, any point on this line is boiling, but where normal pressure is and the temperature we could read down here. Okay, so this is a lot of stuff that's going on. You'll be able to do most of your homework based on this here, but I want to do a couple more advanced things, okay, before I stop our video lesson. I want to make another phase diagram of water because I want you to see that water is a very unique substance. Okay, and so I still want to have my axis for increasing pressure and my increasing temperature. But the phase diagram of water has a very unique difference. We still have a triple point with our sublimation line, and we still have our boiling line, but our line for melting and freezing has a different slope. It actually goes a little bit backwards. So this is still our solid, our liquid, and our gas or vapor phase. But you'll notice most substances have a melting freezing line that slope this way, positive slope. But the melting freezing line for water goes a little bit backwards with a negative slope. And that gives some unique things about water. Okay? So watch out for that. We could put in the triple point and label everything, but it'd be the same. This is the only difference. So some of the questions you'll see on tests will be like, well, what if I don't know, what if I got a little piece of different colored paper, right? And I put it right here. That green piece of paper, that's clearly in the liquid phase, right? Let me move it over here. If I have this liquid and I ask you, what are two ways to get this liquid to boil into a gas? Well, one way is if I were to slide this way, it would turn into a gas. If I could slide this way, that would mean increasing the temperature. You probably knew that. If you want to take a liquid water and make it boil, you increase the temperature. But there's a second right answer. What if we took this and went down? We could take this and slide down into the gas phase, and that would mean not changing the temperature, but changing the pressure. You could decrease the pressure and you would get some liquid to start boiling without even changing the temperature. I know that sounds weird. I could reposition this. What if I put this right here in the solid phase? How can I make solid ice melt? You probably know, well, if I move it this way, I slide into the liquid phase, and that would be melting. But I could also take a solid and increase the pressure, not even change the temperature. Again, if this was our starting point, if we increase the temperature, we could get to the liquid phase, which is different because the line's backwards. If I have a solid and I have it right here and I wanted to make it a liquid, I could go this direction, increase it to be, increase the temperature to become a solid. Or instead of increasing the pressure, if I went up, I wouldn't hit the liquid, But if I happen to be right there, if I drop straight down, I might drop into the liquid. So most substances, if you drop the pressure, you might melt into a liquid. But water, that's not the case. If we have a solid and we drop the pressure, you'll never hit the liquid phase. Maybe you'll get to the gas phase, I guess, but we have that. So this is all about using graphing logic and graphing skills and analysis. Okay, so for your homework, you should have picked this up yesterday in class, and you can add your name to the top, and question number 1 and question number 3, and on the back, question number 7, ask you to put things on this graph to label certain zones and lines and points. Okay, when you go to do this question, I want 2 answers. Not 2 different answers, but 2 parts to the answer. I want a temperature and a pressure. So if you say for triple point, you just give me a Celsius, or you just give me a kilopascal, which is a unit of pressure. That's not right. I want an X and a Y coordinate for number 2. Number 4, you can read, answer both parts. Number 5 is using a graph. Number 6, explain this. And number 8 to 9, you just have to circle the correct answer. Okay, so these will be due when I see you in the next class. I think you should get the phase diagram from our lesson. You should be able to understand it, but we'll go over it a little bit more on our next class day. And you can also check out the other YouTube videos that I put in the Google Classroom for you. All right, take care, keep working, see you soon.